this will be our Y. This will be our what? Our Z. Okay. So now we have to find the principal stress. Okay. At Z is equal to 3.2 meters. Right. The one before we did not need to find, because when shear stress is 0, right? When shear stress is 0 and your normal stress, you have another value, that is your principal stress. Okay. For this case, your shear stress is not equal to 0. Okay. So you have to apply to mole circle. So I'm going to sketch quickly on mole circle now, right? So on mole circle, okay, I'm going to, so this is my Z point. This is my Y point, right? So we know that stress Y is equal to 0. Stress Z is equal to 95.362 megapascal. Your shear YZ is equal to the shear ZY, and is equal to 19.949 megapascal. So we know that. So we want to find the principal stress now. Okay. So as I say, I'm just sketching this. Okay. I'm not sketching to scale. Okay. So we know that this is normal stress, right? And then we know that this is our shearing stress. So this is our normal stress, shearing stress, clockwise, anti-clockwise. We know that over here, this is our stress Y line, right? And then somewhere down here, this is our stress Z line. And then we have shear. You can see the shear is lower, yeah? So as I said, this is just a sketch. So this is our shear, right? And then we have a what? So we have point Z, positive, rotation of element is in the clockwise. So this is our Z. Y will be at 0, anti-clockwise. So this is our point Y. So we draw a straight line, right? So we're going to calculate our principal stress now. So 1.53, 1.5. So this is just a sketch of my mole circle. Does not look really circle, but I have to push this in a bit. Okay, good enough. So now we have to find out what? Stress 1 and stress 2. Okay, so stress 1. So before we do that, again, the procedure is very standard. Okay, the procedure is very standard. So we have center of circle. Which is a stress average. So this will be equal to 95.362 plus by 0 divided by 2. Okay, so 95.362 divided by 2 is equal to 47.681 megapascal. So what we just found out, so this is your stress average, right? Then you look for your tau max, radius of circle. So radius of circle, the maximum, the shear, or this is equivalent to your tau max, right? So this is equal to 47.681 squared plus by 19.949 squared. Okay, so this will be equal to 47.681 squared plus by 19.949 squared Square root of the whole thing is 51.68. Let me do it again. 47.681 squared plus by 19.949 squared. 51.686 megapascal. So stress 1 and stress 2 is equal to 47.681 plus or minus 51.686, right? So for 47.681 plus 0.681 plus by 51.686. So 99.367 megapascal. And the other one is 47.681 minus 51.686 is equal to minus 4.005 megapascal. So you realize that with this with the at point Z equal to 3.2, your structure stress, your principal stress is at where? 99.367, which is lower, right? Which is lower than your principal stress at Z equal to 2.4 at 155. So your structure is able to withstand will able to withstand the loading, and if failure were to occur, it's going to occur at where? At Z is equal to 2.4, and it will be occurring at tau max and not at the junction. Okay, so you have to be really careful. So what do we learn down here? So to summarize, I'm done already. Then we're going to talk about your quizzes very shortly. So what we have learned down here is this, okay? You have to sketch your shear force and bending moment diagram. Then you have to look at points of interest. What do I mean by that? Where you have, where over here you have Z or you have V that's very high. However, moment is low. So you have to check this point because your highest shear force. Then you have to check at 2.4 because you have the highest moment, but your shear is equal to what? 0. And then you have to again check at 3.2 where you have a combination of 32 and a combination of minus 40 kilonewton. Then from there, right, if you have a combination of normal stress or a combination of shear force and bending moment, the failure is going to be at the where? At the junction. In cases where your moment is where? Your moment is at 48 times 10 to the power 3. Right? That is your moment. The failure will occur at where? At the outer surface. Not at the interface anymore. Right? So that's where this value changes. And then back to here at Z. So some of you will tell me, Eugene, so why don't we calculate where shear normal force is equal to shear forces? So if normal the shear stress, the moment is 0, the shear is not very high also, right? So when moment of 0, the shear is not very high. So what you can see down here also very much evident is what? The normal stress is always higher than the what? The shearing stress, right? For this case, we calculated also the normal stress is higher than the what? Shearing stress, right? However, your structure can fail in shear, okay? Your structure will fail in shear. Okay, I will explain why your structure will fail in shear in a lecture next week, right? So I want to talk about your quiz now, okay? I'm going to stop recording.